Good morning, I am Derivation. In this lecture, we are going to discuss about ideal non-inverting amplifier. This topic is present in the subject linear integrated circuits. Ideal non-inverting amplifier. An amplifier which amplifies the input without producing any phase shift between input and output is called non-inverting amplifier. The basic circuit diagram of a non-inverting amplifier using operational amplifier is shown in figure A. Here, the input is applied to the non-inverting input terminal of the op-amp. Non-inverting amplifier representation. The basic circuit diagram of a non-inverting amplifier using op-amp is shown in figure A. Here is a representation. In this non-inverting amplifier, the input is applied to the positive terminal, that is to the non-inverting terminal of the op-amp. Let us discuss about the derivation of closed loop gain for the non-inverting amplifier. The node B is at potential V suffix in. Hence, the potential of the point A is same as point B, which is V suffix in, from the concept of virtual share. That is, V suffix A is equal to V suffix B, that is equal to V suffix in. Consider this is equation 1. From the output side, we can write the current I is equal to V0 minus VA divided by RF. That is, I is equal to V0 minus Vin divided by RF. Here we have substituted the value of VA is equal to Vin from equation 1. Consider this as equation 2. At the inverting terminal, the current I is equal to V suffix A minus 0 divided by R1. That is, the current I is equal to V in by R1. This is the current that is flowing through the resistor R1. Consider this as equation 3. Entire current passes through R1 as input current of the operational amplifier is 0. Now, equating equations 2 and 3, we have V0 minus Vin divided by Rf, that is equal to Vin by R1. That is, V0 by Rf is equal to Vin by R1 plus Vin by Rf. Therefore, V0 by Rf is equal to Vin open bracket R1 plus Rf divided by R1 Rf. That is, V0 by Vin, that is equal to open bracket R1 plus Rf into Rf divided by R1 Rf. This is equal to, in the numerator I will be having R1 plus Rf, in the denominator I will be having R1. Therefore, the A suffix Vf, that is the closed loop voltage gain, is equal to V0 by Vin, that is equal to 1 plus Rf by R1. Consider this as equation 4. Therefore, A suffix Vf is equal to V0 by Vin, that is equal to 1 plus Rf by R1. Equation 4. The positive sign indicates that there is no phase shift between input and output. The input and output waveforms are shown in figure B. Here is the representation of the input waveform and output waveform. While comparing the input and output waveforms, we come to know that there is no phase shift between the input and the output. Let us discuss the features of non-inverting amplifier. The voltage gain is always greater than 1. The voltage gain is positive, indicating that for AC input, the output and input are in phase, while for DC input, the output polarity is the same as that of input. The voltage gain is independent of open loop gain of op-amp, but depends only on the two resistance values. The desired voltage gain can be obtained by selecting proper values of RF and R1. So far we have discussed about the operation of the non-inverting amplifier. Let us discuss about the application of the non-inverting amplifier, that is voltage follower. A circuit in which the output voltage follows the input voltage is called voltage follower circuit. The voltage follower circuit using op-amp is shown in figure below. Here is a representation of the voltage follower. In this voltage follower, the input is applied to the non-inverting input terminal of the op-amp, and the output is taken as feedback and it is connected to the input of the inverting input terminal. This is indicated in this figure. The node B is at potential V suffix in. Now node A is also at the same potential as B, that is V suffix in. Therefore V suffix A is equal to V suffix B, that is equal to V suffix in. Consider this is equation 1. Now node A is directly connected to the output. Hence we can write V naught is equal to VA. Consider this is equation 2. Now equating equations 1 and 2, we get V naught is equal to Vin. Consider this is equation 3. Thus the output voltage V naught is equal to the input voltage Vin. If input voltage V suffix in increases, the output voltage V naught also increases. If input voltage Vin decreases, the output voltage V naught also decreases. Thus, output voltage follows the input. Hence, the circuit is called voltage follower circuit. It is also called voltage follower circuit, unity gain amplifier circuit, or isolation amplifier circuit. So far we have discussed about the theory of the non-inverting amplifier, as well as we discuss about the application of the non-inverting amplifier as voltage follower. Now let us discuss some of the review questions that is present in this topic. Question number 1. An input of 3 volt is fed to the non-inverting terminal of an operational amplifier. The amplifier has Ri of 10 kilo ohms and Rf of 10 kilo ohms. Find the output voltage. This question is asked in Anna University, April 2004. Second question. Deduce the expression for a closed loop voltage gain of non-inverting amplifier. This question is asked in Anna University, November-December 2008 and 17. Question number 3. Compare inverting and non-inverting amplifier. Question number 4. For the non-inverting operational amplifier with input resistance of 100 kilo ohms and the feedback resistance of 900 kilo ohms, find the effect on input voltage due to common mode voltage when the input voltage changes by 1 volts. Assume CMRR as 70 dB. This question is asked in Anna University, April 2003. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.